3x minus 7 equals 2x. You should have gotten x equals 7 there. X equals 7. Let's look at it. So you want all of your variables on one side and all of your numbers on the other. Since you already have a variable over here, it's probably easiest just to move your variables over here. If you moved it the other way, just keep in mind that when you move that over, that turns into a 0. And so then you have to add the 7 over. But if you move them to the right, then we're just going to subtract the 3x. It's a positive 3x, so we want to subtract it to get rid of it, which means we have to subtract it from this side. On the left-hand side, they cancel, and you have negative 7. Negative 7, bring down your equal sign. 2 minus 3 is negative 1x. And we're not done because we want x all by itself, so we have to divide by negative 1. So x equals 7. X equals 7. We have 5 times the quantity y plus 2 minus 4y equals 8y minus quantity 2 plus y. Remember, this is a negative 1 here when you do this, and you should have gotten 2 as your answer. 2 as your answer. Look at that one. All right, so for this one, we have a couple of distributions. We need to distribute this 5. So we're going to say 5 times y is 5y. 5 times positive 2 is positive 10. Then we have a minus 4y equals 8y. Leave that alone. We're going to distribute a negative 1. Negative 1 times positive 2 is negative 2. Negative 1 times positive y is negative 1y. Right? Then we want to simplify each side of this equation. So we want to simplify the left-hand side as much as we can, simplify the right-hand side as much as we can, and then start moving things across the equals. So on the left-hand side, we have a positive 5y and a negative 4y, which is just 1y, and then that plus 10 there. On the right side, we have 8y and negative 1y, so we have 7y, and then minus 2 there. All right, and it doesn't matter which way you move these, again, which side you move them to. I would probably move them over to the right. So I'm going to move the y over, minus y. That cancels out. I have just a positive 10 here. Equals 7 minus 1, that's 6y, and then I have a minus 2. I'm then going to add my 2 over. All right. On the right-hand side, I have just the 6y left. And on the left-hand side, 10 plus 2 is 12. And then my last step here is to divide. So 6 divided by 6 gives me 1y. 12 divided by 6 gives me 2. I know how much everybody loves fractions and decimals, but we are actually going to do a process to eliminate them in the equations so that then you're only dealing with whole numbers or integers when you are subtracting and adding across the equal sign and when you're multiplying and dividing. All right. So all of these involve fractions and decimals, but we're going to do some shortcuts to get rid of them so that you don't have to do, adding or subtracting with common denominators and all that. It does involve common denominators, but we're just going to look at it. All right. So when we want to solve this, you could just say, okay, I'm going to add my 1/3 over. I'm going to combine a 1/4 x and a positive x. And then I'm going to divide by a fraction. But that leaves a lot of room for error when you have that many things going on with fractions. And so one of the methods is just to eliminate the fractions altogether. This does not mean just cross them out and pretend they don't exist. This means we're going to use those denominators to actually get rid of them, okay? And so the first thing you're going to do when you come to a problem like this is you're going to look at all the denominators. So I have a 4 as a denominator and a 3 as a denominator. So my denominators are 4 and 3, all right? And what I'm going to do is I'm going to say, what is the least common multiple between 4 and 3? And if you don't remember how to do this, you just take your greatest one and you just keep doing multiples of that. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Well, 3 obviously goes into 12. So my least common multiple between these two is 12. This is the same process you use to figure out what the common denominator is, okay? So, same process to figure out what the common denominator is. That's your least common multiple. That's what it is, okay? And so between 3 and 4, the least common multiple is 12. So what we're going to do is we're going to take our problem, x over 4 plus x minus 1/3 equals 3. And we are going to multiply every single piece of it by 12. All right? So we're going to take this. Now, because it's a fraction here, I'm going to write this as 12 over 1. So we're going to multiply that by 12. We're going to multiply this by 12. This is also a fraction, so I'm going to multiply this by 12 over 1. And I also have to multiply the thing on the other side of the equation by 12 as well. So I'm going to multiply every single piece of it by 12. I found my least common multiple. Every piece of it I am going to multiply by 12. All right? Once I do that, I'm going to simplify each piece of it. So if I look here, is there anything I can cross cancel? Since you used the least common multiple, I promise there will be. So the 4 and the 12 will cancel, and I will just get 3. 3x over 1. So that is just 3x. 12 times x, that is just 12x. Minus, cross cancel here, the 3 and the 12, cross cancel. I get just a 4. And on the right hand side, I get 36. Okay, so let's walk through this again. We're multiplying everything by 12. Everything by 12. 12 over 1. You can just cancel these guys. 4 and 12. Just think of reducing fractions. Remember, you can reduce top and bottom or diagonally. 12 over 4 reduces to just 3. 12 divided by 4 is 3. 12 times x, that's easy, 12x. 12 over 3, that reduces to 4. 12 divided by 3 is 4. So 4 times 1 is just 4. And then on this side, 3 times 12 is 36. Now, I would think that everybody would agree that this blue equation right here is easier than the first one they gave us. Yes? I would much rather solve this guy than this one. They are the same equation. I multiplied the left and the right side of the equation by 3. My rules of equality say whatever I do to one side, I can do to the other, and it didn't change the equation. All it did was make it easier to solve. It didn't change the actual equation itself, okay? And so now I'm going to do the process I would do to solve this. Combine my like terms, do my addition and subtraction, and my multiplication division to solve for my variable. All right, so for this equation down here, what do? What are my like terms? 3x and 12x. So I have 15x minus 4 equals 36. What's my next step here? I'm going to add 4 to both sides, right? The 4's cancel. I have 15x equals 40. My last step here. Divide by 15. They gave me a fraction. So how do I reduce that? What goes into 40 and into 15? 5. So I'm going to divide by 5. 40 divided by 5 is over 3. That is my final answer. 8/3 is my final answer. So for this one, they actually have groups in the numerator. Okay, they have groups in the numerator. All right. So when they have groups in the numerator, you want to make sure that you take that into consideration when you're doing this problem. All right, so I have this problem here. They want us to solve it. Okay. I'm going to look at just my denominators. I have a 6, a 3, and a 9. So I have 3 denominators here that I need to consider. When you are looking at 3 denominators to define the least common multiple, you take the largest guy and look at his multiples until you find one that all 3 of them go into. All right, so starting with 9. 9 times 1 is 9. 3 goes into 9, but 6 does not. All right, so we're going to have to double. So this is times 1. So times 2 would be 18. So 9 goes into 18. We know that. Does 3 go into 18? Yes. Okay, where did we all go? There we go. All right, 3 goes into 18. What about 6? Yes, all three of them go into 18. That is my least common multiple. So I am going to take all of these and multiply by 18. I'm going to multiply this one by 18. I'm going to multiply this one by 18. And I'm going to multiply this one by 18. When you do this, all of your denominators should cancel because you just chose a number that they all go into. All right? So let's cross cancel. 6 with 18. The 6 will go to a 1. That's what you're trying to do. 18 divided by 6 is 3. Right? 3 goes into 18. How many times does 3 go into 18? 6. And 9 goes into 18. How many times does 9 go 18? 2. All right? So all of my denominators are now 1, so I can ignore them. All right? I can just concentrate on my numerators. All my denominators are gone. Now let's look at this. I have 3 times this group. So you need to make sure that when you do that, you put grouping symbols around it. So even though you don't see them, you need to put grouping symbols there. Minus, I have 6 times this group. I need grouping symbols around it. Okay? And then over on the right-hand side, I just have 2 times 1. So I just have 2. Okay? Everybody see what we did? So now what do? I distribute, combine like terms, move numbers to one side, variables to the other, and then divide. Okay? So I'm just going to distribute here. I have 3 times x, 3 times 2. Negative 6 is what I'm distributing. Negative 6 times x, negative 6 times negative 1. All right? What are my like terms here? I have 2 sets of them. My x's, right? 3x, negative 6x. What does that give me? Negative 3x. And then 6 plus 6. What does that give me? There we go. All right. Next step. What do? What do I do from here? Yeah, I'm going to subtract my 12. All right. On the left-hand side, my 12s will cancel. I have just negative 3x. And on the right-hand side, what's 2 minus 12? Negative 10. So I have negative 3x equals negative 10. What's my final step here? Divide by negative 3. So I have on the left-hand side just an x. What is negative 10 divided by negative 3? Leave it as a fraction. Just 10/3. Negative divided by negative is a positive. It cannot reduce. Nothing goes into 3 and into 10. So we are finished. That is our answer. Okay, so for the first one, we have 3, 8, and 24. You always want to first check to see if your smaller numbers can go into your larger. And in this case, they can. 8 goes into 24 and 3 goes into 24. So your least common multiple here is 24. So we're going to take each piece of this and multiply by 24. So we have x over 3 times 24, x over 8 times 24, and 11 over 24 times 24. For the x over 3, the 3 and the 24 cancel. What is 24 divided by 3? 8. So we have just 8 times x. For x over 8, 24 divided by 8 then is just 3. So we have 3x. And for this one, we have 24 divided by 24. That is just 1. So 1 times 11 is 11. If I combine my like terms, 8x's and 3x's are 11x's. And then I'm going to divide by that 11. And 11 divided by 11 is just 1. All right. For the next one, my denominators are 9 and 3. 3 goes into 9. So 9 is my least common multiple here. So for this one, I am going to multiply the x plus 2 over 9 times 9, the x over 3 times 9, and the 10 times 9. All of them need to be multiplied by 9. For the x plus 2, for the x plus 2, you cancel. It's just a 1. So 1 times anything is just itself. We just have x plus 2 there. Yep, here you divide and you get a 3. So just a 3x. And over here you get a 90. Yeah, it is very important. What is your rule for equations? If you multiply the left-hand side by 9, you have to multiply the right-hand side by 9. Or you did not keep your equation balanced. You only multiplied it one side by 9, which makes it not a balanced equation. All right, on the left-hand side, combine your like terms. Positive 1 and negative 3 give you a negative 2x, and don't forget your plus 2. Then I'm going to subtract that 2 over. So on the left-hand side, I have negative 2x. 90 minus 2 is 88. And then my final step is to divide by negative 2. So the negative 2 and the negative 2 cancel, and 88 divided by negative 2 is negative 44. Example 3, it says the coach has developed a drill that requires a rectangular field with the width being 1/3 of the length. The perimeter of the field is 280 feet. What length and width should the field liner mark off? Okay, so perimeter. Remember, we're adding, all of the pieces of the perimeter. So we're adding 2 of our widths, right? And 2 of our lengths to get the perimeter. All right, we can write it like this, right? But we're just, that's all our perimeter is, adding up all the sides of a rectangle, okay? It says the width is 1/3 of the length. So I don't know what my length is, but I know that my width is 1/3 of that. Right? Everybody see that? Yes? So I don't want to use 2 different variables. If I say 2w plus 2l equals 280, I have 2 variables, so that's not going to help me. But if I write my width in terms of my length, that's going to help me. So instead of writing 2 times w, I am going to write 2 times 1/3 my length. That's my w. Plus 2 of my lengths, right? 2 of my w's, 2 of my lengths. And that equals my perimeter. They told me the perimeter of the field, 280. Okay?
Wait, so.
Okay. Right, so 2 times 1/3. What is 2 times 1/3, by the way? 2 over 1 times 1 over 3 is 2 over 3. Yes? All right. So here's the deal. I have a denominator. Now what's nice about this one is I only have one denominator. So my common denominator is that denominator, right? So I can multiply everything by 3. I'm going to multiply this by 3. I'm going to multiply this times 3. And I'm going to multiply this times 3. All right? My 3's cancel. So I just have 2l plus, what's 3 times 2? 6l equals, so just multiply it out, 3 and 0, 3 and 8, 3 and 2, right? Plus 2. All right, so I am going to combine my like terms. How many l's do I have? 8 l's, 840, and then I'm going to divide by 8. So when we have 840 divided by 8, so just do it one at a time. 8 goes into 8 how many times? 1, and 8 goes into 40 how many times? 5, 15. I solved for my sorry, 0. I need a 0 there. So 0, 5. I solved for which one? Length? Am I done? No. So my width is 1/3 of that. How do I find my width if I have my length? Yeah, divide by 3, right? Multiply by 1/3 is dividing by 3. So what's 105 divided by 3? 3 goes into 10 how many times? 3 with 1 left over. 3 goes into 15 how many times? There we go. So the bottom of page 85, it tells you when you have fractions, you find the least common denominator. The way you get rid of all your fractions is you multiply every single piece of your equation by that least common denominator. And then all you're doing is solving the equation. You'll have all whole numbers at that point, and you'll do what we've been doing. Combine any like terms, variables to one side, numbers to the other, and then divide. Okay? Those are your steps. All right, so another thing that becomes a little tedious when you're solving is when you have decimals involved. Because your rules of decimals, when you multiply, you have to, add your decimals up. When you have to divide, you have to move them over. When you're adding, you line them up. And so oftentimes when you have decimals in an equation, you leave a lot of room for error. Because even if you know the number piece of it or how to solve it, you mess up in just the straight addition, subtraction, multiplication, division of the decimals themselves, okay? And so the trick to getting rid of this is actually even simpler than the fractions. So we have 2.6 times x plus 12.24 equals 0.27 times x minus 6, all right? So when I look at this type of problem, I'm going to say, what is the most decimals any one number has? So what's the most decimal places that any one of these numbers has? 2. All right, and so what I'm going to do is I'm going to move every single one of these over 2 decimal places. All right, I'm going to take this 2.6 and I'm going to move it over 2 decimal places. What happens when I have a gap there, when I have decimal places? I put a 0, so that becomes 260x, okay? And then plus, I'm going to move this one over 2 decimal places. That becomes 1,224, all right? And then I'm going to move this over 2 decimal places, and that becomes 27x minus 6. Basically what I did is I multiplied everything by 100. That's what I did. And I can do that because I multiplied every single piece on both sides by 100. But it's easier just to count the decimals and move them over the most number of places. So good question. If you have parentheses, you can multiply just what's on the outside by that 100, or just move what's on the outside's decimal places. Don't touch the inside. It will be accounted for when you distribute, okay? When you distribute, you will already be taking that 100 with you. All right? Now, while these are big numbers, you're not dealing with decimals or fractions, okay? And so we're going to handle this just like we would. If let's say we had distributed first, we would have had 0.27 times x minus 0.27, which is what, 162, so 1.62 here, okay? And then when I moved everything over, I would get 27 and 162. That's exactly what I'm getting down here when I distribute. So it's easier to do it first than to distribute with your decimal. All right, so let's take the next piece of it. The next piece would be to distribute this. So I'm going to leave this side alone. 260, 1224, 27 times x is 27x. 27 times negative 6 is negative 162. All right? Which is why we didn't have to touch what was in parentheses. It's already accounted for when we do this. All right? These are going to be big numbers, so all right, so let's look at this one. We're going to move all my numbers to one side, all my my variables to the other. So minus 1224. These cancel. This is a negative minus, so we just add and keep it a negative. Remember, it's adding the opposite. So I'm just going to add this down. All right, 1386, just add it down and make it negative. Remember, when you're adding 2 negatives, you just add and keep them negative. And then I'm going to oh wait, it's minus, not equals. I'm just going to move my variables over. So I'm going to move my variables over. All right, so now I need to move this guy over here by subtraction. And again, you will not have one quite this large because I'm not going to want you to spend all your time dividing that big guy. He ends up being a decimal. Again, I'm not going to give you one this large where it ends up being that big of a decimal. It actually ends up being a rounded decimal. All right, but I wanted you to see the process. Yeah, it's actually 5.95 when you divide. The most common place of seeing these decimals is with money and with coins, all right? So hopefully you know your coins, right? From like, I don't know, first grade. But hopefully you know your coins. Chris has 17 coins. They are all dimes and quarters. All right, all dimes and quarters. If he has a total of $2.45, how many of each does he have? All right. We don't know how many dimes and quarters he has. All right. But we know he has a total of 17. So if he has, dimes, then 17 minus the number of dimes will be how many quarters he has. Does everybody see that? That's the total number, right? That's how it works. Dimes are worth how much a piece? 10 cents. Quarters are worth how much a piece? 25. And how much money does he have altogether? 245. What's the most number of decimals that I have? 2. How many places I'm going to move everybody over? 2, 2, and 2. So I get 10, 25, yes, and 245. So this is a way to easily solve this guy.